January 17, 1940. Wolfsburg, Germany. The morning fog clung to the cobblestone streets as Oberingenieur Klaus Reinhardt stepped through the iron gates of the Volkswagen production facility. His breath crystallized in the winter air, mingling with the acrid smell of coal smoke that poured from the factory chimneys. Inside, the floor trembled with the methodical percussion of German precision, each rivet placed with mathematical certainty, each component machined to tolerances measured in fractions of millimeters. Reinhardt ran his calloused fingers along the smooth steel of a freshly milled crankshaft, feeling the perfection of German engineering beneath his touch. On the wall behind him, a propaganda poster displayed the Führer's vision, Kraft durch Freude, strength through joy. But Reinhardt's joy came from something else entirely, the absolute certainty that German industrial mastery stood unrivaled in the world. That morning, like every morning, he believed this with the fervor of religious conviction. Across the Atlantic, American factories told a different story, or so the German engineers believed. In their technical journals and military briefings, America was portrayed as a nation of frivolous excess, where assembly lines produced refrigerators and automobiles for a soft civilian population grown fat on luxury. The Germans had studied American industry with the same meticulous attention they brought to all things, and their conclusion was unanimous. American manufacturing was quantity without quality, mass production without the soul of true craftsmanship. They had seen the photographs of Detroit's automotive plants, sprawling and chaotic compared to the ordered efficiency of German facilities. They had read reports about American workers, unionized, undisciplined, more concerned with coffee breaks and baseball games than the sacred duty of production. In the conference rooms of the Reich Ministry of Armaments, senior engineers passed around examples of American consumer goods with barely concealed contempt. A toaster that broke after 2 years. An automobile designed for obsolescence. A culture that valued convenience over permanence, speed over perfection. This was not mere arrogance, it was calculation built on observable evidence. Germany's industrial philosophy was rooted in centuries of guild tradition, where master craftsmen passed knowledge through generations, where the creation of anything, a sword, a clock, a machine, was an act of almost spiritual dedication. The German engineer was not simply a worker, but an artist of function, a priest of precision. When they looked at their tanks, their aircraft, their U-boats, they saw the culmination of this tradition. The Panzer III's transmission was a masterpiece of mechanical engineering. The Messerschmitt Bf 109 represented the apex of aerodynamic design. The Krupp Steel Works produced armor plate of such quality that it set global standards. How could a nation that mass-produced cheap consumer trinkets possibly compete with this level of excellence? The Germans had forgotten something crucial, or perhaps they had never understood it at all. They had mistaken American abundance for American weakness. They had confused civilian prosperity with industrial incapacity. They were about to learn the difference between craftsmanship and capacity, between precision and production, between making things perfectly and making things fast enough to bury an enemy beneath an avalanche of steel. Detroit in 1940 was not preparing for war. It was barely thinking about war. The automobile capital of the world hummed with the business of peacetime prosperity. Assembly lines in sprawling factories produced Fords, Chevrolets, Chryslers, Packards, nearly 5 million vehicles every year, more than the rest of the world combined. The River Rouge complex in Dearborn stood as the largest integrated factory on Earth, a city-sized monument to industrial automation where raw materials entered one end and finished automobiles emerged from the other. Iron ore arrived by Great Lakes freighter, was smelted in blast furnaces, rolled into steel, stamped into body panels, assembled into vehicles, and driven away by buyers, all within a single, continuous industrial process. Yet to German observers, this was merely proof of American superficiality. Making cars for housewives was not the same as making weapons for warriors. Then everything changed. Not gradually, not with warning, but with the sudden violence of a switch being thrown. When the United States entered the war in December 1941, American industry didn't transition to military production, exploded into it with a force that rewrote every assumption about industrial capacity. The factories that had been making sedans and refrigerators were retooled with stunning speed. The same assembly lines that produced civilian comfort now began producing military devastation. And the scale, the sheer incomprehensible scale, left German engineers struggling to believe their own intelligence reports. William Knudsen, the Danish immigrant who had risen to lead General Motors, was summoned to Washington just months after the war began in Europe. President Roosevelt appointed him director of the Office of Production Management with a simple mandate: prepare American industry for war. Knudsen knew Detroit's capabilities better than any man alive. He had pioneered the moving assembly line techniques that made Ford's success possible. He understood that American manufacturing wasn't built on the German model of artisanal perfection. It was built on something far more powerful: the ability to break complex processes into simple, repeatable steps that could be performed by workers with minimal training, at speeds that defied traditional manufacturing logic. When Knudsen returned to Detroit with the government's requirements, tens of thousands of aircraft, hundreds of thousands of vehicles, millions of rifles, he didn't flinch. He simply began making phone calls. The Willow Run plant would become the symbol of everything Germany had misunderstood. Ford broke ground on the massive bomber factory in April 1941, 8 months before Pearl Harbor. The building itself was a statement of intent: a single room 3,000 feet long and nearly a quarter-mile wide, enclosing 67 acres under one roof. Charles Lindbergh, the famous aviator, toured the facility during construction and declared it impossible. No factory could be that large and function efficiently. The logistics alone would create chaos. But Ford's engineers had studied their own automotive plants and understood something profound: if you designed the process correctly, size became an advantage rather than a liability. The same principles that allowed them to produce a Model T every 45 seconds could be applied to aircraft production. When Willow Run reached full production in 1944, it produced a B-24 Liberator heavy bomber every 63 minutes. Not every day, every 63 minutes. The 4-engine aircraft that required 18,000 individual parts emerged from the assembly line at a pace that made traditional aircraft manufacturing look like handicraft. By war's end, Willow Run alone had produced nearly 9,000 B-24s, more than half of all Liberators built. A single factory in Michigan outproduced entire national industries. German intelligence officers examining captured documents refused to believe the figures. They assumed the numbers were propaganda, inflated to deceive and demoralize. They were not. Oberingenieur Reinhardt, who had once run his fingers over German crankshafts with such pride, found himself transferred to an intelligence unit by late 1942. His task was to analyze American industrial capacity and provide realistic assessments of enemy production. The reports that crossed his desk became increasingly surreal. American tank production exceeded German output by factors of 3, then 4, then 5. American aircraft production reached numbers that seemed typographically impossible: 50,000 planes in 1942, 86,000 in 1943, 96,000 in 1944. The Americans were producing more aircraft in a single month than Germany had produced in the entire year before the war. Reinhardt checked the calculations again and again, certain there must be errors. There were no errors. The fundamental difference was philosophical, not technical. German industry operated on the principle of optimization: each component machined to exacting tolerances, each design refined to engineering perfection. A German tank transmission was a marvel of mechanical design, built to operate for thousands of miles under extreme conditions. It was also complex, requiring skilled machinists to produce and experienced mechanics to repair. When a Panther tank broke down on the Eastern Front, it often required specialized tools and replacement parts that had to be shipped from Germany. American tanks were different. The M4 Sherman wasn't as heavily armored as German tanks. Its gun wasn't as powerful. Its transmission was simpler, less refined. German crews who encounter Shermans in battle often destroyed them easily. One Tiger tank could take out 5 Shermans in a single engagement. But the Americans built 50,000 Shermans. The Germans built fewer than 2,000 Tigers. When 5 Shermans were destroyed, 5 more appeared the next day, and 5 more the day after that, and the day after that, in an endless, grinding procession that no amount of German engineering excellence could overcome. The symbolic object that came to represent this crushing abundance was absurdly mundane: the jerry can. The Germans had invented it, a brilliantly designed fuel container with an X-shaped indentation that allowed the can to expand and contract without rupturing, with 3 handles so one soldier could carry 1 can or 2 soldiers could carry 1 can between them, with a cam lever cap that sealed perfectly and opened without tools. It was like so much German engineering, nearly perfect in its execution. The Wehrmacht depended on these cans to fuel their mechanized forces. When British and American troops captured German jerry cans in North Africa, they immediately recognized their superiority over Allied fuel containers. The British began copying the design. The Americans did the same. But while the Germans could produce hundreds of thousands of jerry cans, American industry produced tens of millions. By 1944, American factories were manufacturing jerry cans so quickly that they were being used as disposable containers. Fuel was poured into vehicles, and the empty cans were often left behind or given away to civilians. A German invention, perfected through careful engineering, had been transformed by American industrial capacity into a commodity so abundant it had lost all value. This pattern repeated across every category of war material. The Germans designed the world's first operational jet fighter, the Me-262, a revolutionary aircraft that could outperform any Allied plane in the sky. German engineers spent years perfecting the jet engines, solving complex problems of metallurgy and thermodynamics. When the Me-262 finally entered combat in 1944, it was a masterpiece, fast, deadly, technologically decades ahead of its time. Germany produced approximately 1,400 of them. Meanwhile, American factories were producing conventional aircraft at such rates that the German jets barely registered as a strategic factor. The Americans flew 20,000 bomber sorties in a single month. They could afford to lose hundreds of aircraft. The losses were simply replaced. German pilots flying their technological marvels found themselves outnumbered 50 to 1, then 100 to 1. Perfection became irrelevant in the face of overwhelming quantity. The transformation wasn't merely industrial, it was ideological. American factory workers weren't Prussian craftsmen devoted to mechanical perfection. They were farmers' daughters from Michigan, steelworkers from Pennsylvania, black workers from the South, who had migrated north for employment, women who had never worked outside their homes until the war. The famous Rosie the Riveter wasn't a mythical figure. She represented 6 million American women who entered the industrial workforce during the war, performing jobs that German engineering tradition reserved exclusively for extensively trained male craftsmen. At bomber plants across the country, women in bandanas and coveralls operated pneumatic riveters, assembled wing sections, installed hydraulic systems. Inspectors were initially skeptical. Could workers with minimal training really build aircraft to military specifications? The answer was yes, because the manufacturing process had been so thoroughly systematized that individual craftsmanship became unnecessary. You didn't need to understand the principles of aerodynamics to rivet a wing panel. You just needed to follow the process exactly as designed. This democratization of production was fundamentally American in character. The assembly line didn't just make manufacturing faster, it made it more egalitarian. Anyone could work on an assembly line with brief training. Skills that took German apprentices years to master could be broken into component steps that require days or weeks to learn. This wasn't degrading work, though German observers saw it that way. It was liberated work, freed from the constraints of guild tradition and aristocratic credentialism. The farmer's daughter who riveted bomber fuselages in Willow Run was participating in the same industrial democracy that had made Henry Ford's fortune possible. She earned good wages, saved her money for the future, and proved every day that American abundance was built not on some mysterious national character, but on systems of production so efficient they could absorb virtually unlimited labor and convert it into unlimited output. German engineers, when they finally understood what they were facing, experienced something close to existential horror. Reports from the Eastern Front described Soviet production that seemed impossible. The Russians were building T-34 tanks faster than German forces could destroy them. But at least Soviet production could be explained through savage logic. Stalin was willing to throw millions of workers into factories under brutal conditions, accepting massive casualties and slave labor to maintain output. The Americans were different. They were producing war materials at Soviet rates while maintaining civilian prosperity. American factories operated around the clock in 3 shifts, but workers weren't starving, weren't being coerced. They were earning overtime pay, buying war bonds, living in modest comfort even as they outproduced the entire Axis combined. Grocery stores in American cities remained stocked with food throughout the war. Civilian automobile production stopped, but households kept their existing cars. Rationing existed but was relatively mild compared to the privation in Germany, where by 1943 civilians were subsisting on increasingly meager rations while every resource was diverted to military production. The symbolic object evolved as the war progressed. By 1944, it wasn't the jerry can anymore. It was the C ration, the standardized combat meal that American soldiers carried everywhere. Each box contained enough calories for a day's operations, packaged in ways that prevented spoilage, designed for consumption without preparation. The rations weren't gourmet. Soldiers complained constantly about the monotonous taste, but they were abundant, reliable, present everywhere American forces operated. German soldiers who captured American supplies were consistently shocked by the quantity and quality of American rations. Wehrmacht troops on the Eastern Front were often subsisting on black bread and thin soup. American soldiers were complaining about having to eat canned ham again. The contrast wasn't subtle. It was obscene, offensive to German soldiers who had been raised on propaganda about decadent Americans unable to endure hardship. Here was evidence that America could fight a global war on multiple continents while keeping its soldiers better fed than German civilians. The Italian campaign provided particularly bitter lessons. When German forces in Italy captured American supply depots, they found stockpiles that defied belief. Mountains of ammunition, warehouses of fuel, acres of vehicles and equipment. American logistics operated on the assumption that everything would be available in excess. If a unit needed 1,000 rounds of ammunition, they were supplied with 10,000. If they needed fuel for a week, they received fuel for a month. This wasn't inefficiency, it was strategic abundance. American commanders never had to worry about rationing supplies or conserving ammunition. They could fight with the profligate expenditure of materials that overwhelming production made possible. Artillery barges that German forces would have considered wasteful were standard American tactics. When American forces encountered resistance, they didn't maneuver around it with tactical elegance. They buried it under artillery fire, called an air strikes, brought up overwhelming firepower until resistance collapsed. This was warfare transformed by industrial capacity into something almost geological, as if American forces were less an army than a force of nature, grinding forward with the inexorable patience of a glacier. By 1945, German engineers who had once mocked American industry found themselves in ruined factories, watching Allied bombers pass overhead in formations so large they darkened the sky. The American 8th Air Force could dispatch 1,000 heavy bombers in a single raid, each aircraft carrying several tons of high explosives. The mathematical reality was inescapable. American factories had produced more bombers than Germany had produced fighter aircraft. The assembly lines that once made automobiles for suburban families now made the weapons that were systematically destroying German industrial capacity. The Ruhr Valley, heart of German steel production, was reduced to rubble. The ball-bearing plants at Schweinfurt, vital for manufacturing, were flattened. The synthetic oil refineries that kept German forces mobile were turned into smoking craters. And still the bombers came, wave after wave, because American production could replace losses faster than German air defense could inflict them. Reinhardt survived the war, though his world did not. He was captured by American forces in April 1945 during the final collapse of Nazi Germany. The Americans processed him through a POW camp with mechanical efficiency, paperwork, medical examination, interrogation, classification. The camp was run with the same systematic precision that characterized American production. Meals arrived on schedule. Medical care was available. The guards were professional rather than sadistic. Reinhardt found this somehow more humiliating than brutality would have been. The Americans weren't angry at their prisoners. They were simply processing them, converting captured enemy into sorted categories with the same methodical approach they brought to every logistical challenge. He spent months in that camp, watching American supply trucks arrive with regularity that would have been impossible for German logistics to maintain. Every truck was identical, stamped out by the hundreds of thousands. Every crate of supplies followed standardized formats. The Americans had industrialized not just production but everything, transforming warfare itself into an assembly line process. After his release, Reinhardt returned to what remained of Wolfsburg. The factory where he had once felt such pride was a skeleton, its roof blown away by bombs, its machinery either destroyed or hauled off by Soviet occupation forces as reparations. He walked through the ruins in the summer of 1946, remembering the morning fog and coal smoke of 1940, the certainty he had felt about German superiority. That certainty seemed impossibly naive now, almost childish. How had they been so blind? The evidence had been available all along. American industrial output figures were published openly. Democratic societies didn't hide their production statistics. But German engineers had looked at those figures and dismissed them as propaganda or attributed them to low quality. They had made the fatal mistake of conflating excellence with efficiency, perfection with productivity. They had believed that making superior products was the same as winning industrial competition. They had been wrong. The Marshall Plan brought American aid to Germany in 1948, and with it came American engineers, American advisors, American methods. Reinhardt found work again, this time helping to rebuild German industry using American techniques. It was humbling work for a man who had once believed Germans had nothing to learn from Americans. But the lessons were undeniable. The Americans taught simplified production processes, standardized components, assembly line techniques adapted from automotive manufacturing. German industrial recovery happened with stunning speed, driven by American investment and American industrial philosophy. The very methods that German engineers had mocked before the war became the foundation for Germany's post-war economic miracle. By the 1950s, German factories were producing with American efficiency, and German engineers had finally understood what American industrial power had demonstrated so catastrophically: that abundance was its own kind of excellence, that the capacity to make millions of adequate products would always defeat the ability to make thousands of perfect ones. The symbolic object in the post-war years became the Coca-Cola bottle. American soldiers had brought Coke with them to Germany, and after the war it became ubiquitous, a small glass bottle of sweetened carbonated water that somehow represented everything about American industrial culture. It was standardized, mass-produced, identical from one bottle to the next. It wasn't sophisticated or refined. German beverages had centuries of tradition behind them. But Coca-Cola was everywhere, desired by everyone, a product so successfully manufactured and marketed that it had become almost a universal currency. Children begged for Coke. Adults served it at celebrations. The simple bottle, produced by the millions, had accomplished what German beverage traditions could not. It had conquered the world through sheer industrial persistence. There was a bitter poetry to this transformation. The nation that had valued craftsmanship above all had been defeated by mass production. The culture that celebrated individual mastery had been overwhelmed by collective efficiency. German engineers had believed that quality was a virtue unto itself, that making things perfectly was its own reward and its own strategic advantage. They had learned at the cost of everything that perfection was a luxury affordable only to those who weren't fighting for survival. In total war, adequate weapons delivered in overwhelming numbers would always triumph over perfect weapons delivered in limited quantities. The mathematics was brutal and inescapable. American industry had transformed not just the outcome of World War II, but the nature of industrial competition itself. In the post-war world, manufacturing excellence was measured not by the tolerances of individual components, but by the efficiency of production systems, not by the skill of master craftsmen, but by the capacity of integrated supply chains, not by the perfection of finished products, but by the speed with which they could be replaced. The lessons Detroit taught were lessons the entire world would learn. Japanese manufacturing, rising from its own wartime devastation, would adopt American production methods and add its own innovations, eventually surpassing American industry in automotive production by the 1980s. Chinese manufacturing would take these same principles to even greater scales, becoming the world's factory through systems of production that prioritized volume above all else. The industrial model that began with Henry Ford's assembly lines and matured in the crucible of World War II production became the template for global manufacturing in the late 20th century. But there was something else in those ruins where Reinhardt walked in 1946, something beyond industrial theory and production statistics. There was the ghost of an ideology that had believed superiority was destiny, that excellence in engineering reflected some deeper racial or cultural supremacy. The Nazis had made engineering a component of their racial mythology. German technical prowess was evidence of Aryan superiority, just as German military victories were proof of biological destiny. When American industry buried the Wehrmacht under an avalanche of mass-produced weapons, it wasn't just defeating an enemy, it was refuting an ideology. The farmers' daughters and black workers and immigrant laborers who built American bombers and tanks had proven that industrial capacity was democratic, not aristocratic, that production was a matter of systems and capital rather than breeding or tradition. The very existence of Willow Run was a rebuke to fascist ideology, demonstrating that free people voluntarily working for wages could outproduce slave labor and conscripted craftsmen. This was the larger truth that the post-war world would have to accommodate, that abundance itself was a political statement, that the capacity to produce enough for everyone was a form of power more enduring than military conquest. American democracy and American industry were not separate phenomena, but expressions of the same underlying principle, that systems designed to maximize participation and efficiency would always outperform systems designed to preserve hierarchy and tradition. The soldiers who stormed Omaha Beach carried rifles that had been made in their thousands, wore uniforms that had been manufactured by the millions, rode in landing craft that had been mass-produced with the same techniques used to make automobiles. They weren't superior soldiers in the sense German military tradition understood superiority. They weren't members of a warrior elite trained from childhood in martial values. They were civilians in uniform, ordinary men made extraordinary by the industrial might that armed them and the democratic faith that motivated them. 63 minutes per bomber. That was the rhythm of American industrial power at its peak, the mechanical heartbeat of democratic abundance. In the time it took a German craftsman to machine a single precision component, an American assembly line produced an entire 4-engine bomber. This wasn't magic or some mysterious American character trait. It was the logical outcome of industrial systems designed for maximum output, implemented by a society wealthy enough and organized enough to make those systems function. The B-24 that rolled out of Willow Run every 63 minutes wasn't just an aircraft. It was a philosophical argument made physical, a refutation of every assumption about craftsmanship and quality, and martial virtue that German engineers had held sacred. It was proof that abundance could be engineered, that plenty was a choice rather than an accident, that freedom and productivity were not enemies but allies. In the end, that was what German engineers had failed to understand in 1940 when they mocked American industry. They had mistaken civilian prosperity for military weakness, not realizing that a society capable of producing abundance in peacetime could redirect that same capacity to produce devastation in war. They had assumed that soldiers raised on luxury would be soft, not understanding that soldiers who knew what they were defending, the very abundance and freedom they had grown up with, would fight with desperate determination to preserve it. They had believed that careful engineering and racial superiority would overcome mere numbers, forgetting that wars are won not by perfect weapons, but by adequate weapons delivered in quantities that break the enemy's ability to resist. The factories of Detroit returned to peacetime production after 1945, and the assembly lines that had made bombers went back to making automobiles. But the lesson remained written in the ruins of German cities and the memories of men like Reinhardt who had learned it too late, that industrial democracy was not just an economic system, but a strategic asset, that abundance was not weakness, but overwhelming strength, that the nation which could arm everyone had already won the only war that mattered, the war of production, the war of capacity, the war of bottomless, crushing, remorseless plenty. The engineers who had once mocked America's inability to craft perfection had discovered what perfection meant in the mathematics of total war. It meant 63 minutes per bomber, 50,000 tanks, 6 million women in factories, unlimited ammunition, endless supplies, and the certain knowledge that however many were destroyed, more would arrive tomorrow, and the day after that, until victory became not a hope, but an industrial inevitability. As predictable as the turning of assembly lines and as unstoppable as the rhythm of American production.